So I'd love to start at the highest level. I mean, obviously it's been a crazy last few months in the world of AI, with seemingly a new big thing announced like almost daily. It felt. Maybe walk us. What is going on, and why?
I guess I'll take a crack, and then Melanie can kind of pick up. For me, it feels like an overnight success, 70 years in the making. So, the progress of machine learning and NLP over the past, let's say, even just 2 decades, has been immense. From the availability of cheap compute to automatic differentiation in the form of things like Torch and PyTorch. There were a lot of pieces that kind of led to the moment that we're having now. And one of the things that people usually talk about, the availability of GPUs and of cheap compute. NVIDIA is rightly credited for kind of bringing this forward. But along the way, there were a lot of software pieces. Automatic differentiation libraries was one. Deep learning that was kind of built on top of these libraries was another one. And then transformer architecture is a third piece. Once I think all of those, and the fifth part is also the open source and sharing of the community. It didn't have to be that way, but for whatever reason, the academic machine learning community happened to be one that shared quite a bit. So companies like Hugging Face and Google's Colab, enabled sharing of code, sharing of technology, and this just really increased the pace of innovation. And all these pieces have enabled a pace of innovation which has increased and increased and increased. And so to bring back to this moment, ChatGPT I think came out, I don't know, a month or 2 months ago, but 2 years ago I remember being shocked at GPT-3 when it was released, because it was just so. I'm an old NLP guy, and it was so vastly better than anything that we could build for decades. And so looking at GPT-3, it was kind of the first thing. People had been scaling up and scaling up. They'd had smaller models. I think GPT-2 was like I don't know, Melanie, you'll correct me. I think it was like a 10 billion parameter model, somewhere around there. Might have been 2, and it was not large. And then they scaled up, and they got this vast increase in performance. And it was so quick that just the pace between those two things, between GPT-2 and GPT-3, that you kind of had the sense that oh my God, something's going to come. It's going to be a big deal. And so the last 2 years, I think it's been this increased frenzy, at least in the machine learning community, of, oh my God, okay, it's going to be here, it's coming.
Melanie, can you talk maybe about the multimodal aspect of this, and the fact that it seems to be suddenly a bunch of things like text and images and videos, and where does that come from? Why is that suddenly possible?
Yeah, I mean, so I think it's a combination of things as well, like many of the ones that Gideon mentioned already, scale and open sourcing and sharing, and advancing of the different architectures, right? Like, so we're seeing these stable diffusion models and also transformer models be used for new types of modalities. There's a lot more people collecting a lot more data. So data is a really important, when we say scale, we don't just mean scale of the size of the models and the number of parameters of the models, although that definitely helps performance in a lot of cases. We also mean the scale of the data. So I guess this group will appreciate that, like, the data is extremely important. So both the quantity and the quality of that data. And so I think like those have been really increasing, and people have just been exploring, new ways to use generative AI. So I think there's a lot of excitement about what this stuff can be used for. We've been finding some advantages of combining multiple modalities. So sometimes your model gets better when you combine, say, text and speech, or text and speech and images, depending on the way you train it and the type of data you have and the tasks that you want to perform with that model. So all of those things are helping multimodal become better. But especially, I think the types of products are amazing. So now we have voice models that can listen to 3 seconds. I think we had recently this new volley of your voice and then replicate your voice. We have models that can get like a very short sentence and generate like minutes long video that describes like exactly what you're saying in the sentence of something that you've never seen before. So it's getting pretty cool. Yeah,
a little bit to that theme, like almost taking your, Meta and Bloomberg hats off, but just as industry practitioners, like what do you find is particularly interesting in this whole sea of new things, and versus what might be a little overblown, favorite products, favorite companies, favorite things to look at?
Sure. Favorite is very hard. I think it's really exciting that people are starting to figure out how to apply these models to generative use cases in production, because that's actually been a big challenge historically to get generative models working well enough that, like, safely enough. For example, text models can say accidentally like very harmful things, biased things, toxic things, and images, you can use your imagination. I'm sure how people could abuse those. So I think some of the advances in safety that are allowing us to actually use these in, we haven't solved it all the way, but some of those advances are really cool. And then there are so many cool startups I can't even pick. Some ex-colleagues are doing this very, very cool one called Character AI. That one's super fun. You can like talk to like anyone, basically. The chatbot can do anything. And yeah, I really love the generative 3D work that's happening at some startups and companies, because I think that, that's kind of, I have to say it for being from Meta, but that's kind of like how the metaverse is going to happen. We're going to be able to like walk around in generated 3D worlds in VR, and they're all going to be built much more quickly than maybe we expected a few years ago.
The part which I think is really interesting, at least for me, is that it's never been possible to give an instruction to a computer before and have any hope in natural language, and have any hope that the computer was going to be able to understand what you wanted and more or less carry it out. And it kind of works out of the box. And there are a lot of asterisks and caveats to kind of like when it works and when it doesn't work, what the failure mode looks like. But certainly it's better than anything before. Just to give an example, we spend a lot of time on one of the things that we do for Bloomberg and for Bloomberg Terminal is, Bloomberg Terminal is a piece of software that gives you access to financial data analytics and news that is important to many, many people in the financial community. One of the things that we've been working on for many years is search function, like an enterprise search into that data, and really a natural language search into that data. And we've tried lots of things. We've written regular expressions. We have semantic parsers. We have some really, I don't know if you knew we had some like fancy neural semantic parser induction stuff. We have a lot of manual work. We have a lot of machine learning. It's hard. It kind of works. It gives some value. It never has kind of realized what we really want. And when I look at all of the LLM technology, large language model technology, it seems like it will get closer than any of the things that the field has been doing for the past few decades.
So what's missing for all of this? I mean, it's a moment of excitement. We all see the possibility. Where's the gap and between this and LLMs and being deployed in production everywhere? Is that a scientific gap? Is there some stuff we don't know how to do yet?
So I don't think the gap is far. First of all, they're already plenty of people deploying this technology in startups. Notion AI had a cool deployment already. TikTok has some generative AI. So I don't think we're far from seeing it in production, but there are some challenges. So one of them is compute. These are really expensive models to serve generally. So we are making some advancements, but we have to advance more on inference efficiency, so serving these things faster and more cheaply. The models also, especially the language models, have some, both language models and multimodal have lots of problems. So I'll say language models, hallucination is a big problem. Hallucination is what we call the model very confidently saying something right that's actually wrong. So maybe...
Sounds like a venture capitalist.
Yep, so you might have seen ChatGPT got banned from Stack Overflow because it sounded convincing but wasn't quite right all the time. And then different kinds of responsible AI and safety. So like I was mentioning before, we haven't totally solved these bots generating things that are considered harmful. And of course, this can be a little bit subjective too, like what's harmful. Like if you ask the bot something like, is Taiwan a country? Like that's a subjective potentially answer. So you have to think about all this local context and subjective safety issues, as well as sort of just things that everyone recognizes are wrong that aren't totally solved. And then the final one that's really tricky is privacy and data ownership. So with these bigger and bigger models, especially even if we don't scaling up the size of the models, we're usually scaling up the data. You're usually ingesting stuff that someone else owns and might not want you to put in a large generative model and spit out something very similar. And so there's a lot of discussions happening on like, how should we be attributing the sources? Like what sources can we use? What kind of licenses do we need? That kind of, I think will be forced to happen eventually, but some people are ignoring for now.
So far, the most widely deployed application of the large language models is probably Copilot. Actually, how many of you in the audience have ever tried Copilot? How many of you love Copilot? Okay, Copilot. Yeah. So Copilot is a autocomplete. It's basically a fantastically good autocomplete for code, and you can enable it as part of VS Code or NeoVim. I think there are a few other IDEs that it's integrated, but it's just much better than anything before and completes longer. They've done some studies, and studies suggest that it saves about 40% for new code, for developers to write new code. It's a big deal. And what's interesting about that, so Matt, to your question, I think there's already some deployment in certain scenarios of large language models, in particular in Copilot. And I think what's interesting about the Copilot scenario is that programmers, professional programmers, and anybody who's programming can look at the output and very quickly decide either visually or by running the thing whether that's doing what they want. And I think that question of it's not actually truthfulness or truthiness, but it's some element of verification or of assessment that what is getting out is serving your purpose. I think that's going to be one of these evergreen problems for LLMs, and we're going to keep trying to chew on that for a while. But that's going to be the big blocker of a lot of the further deployments.
Is there a line of sight to some of these issues being resolved, or is it going to be one of the things where to get to the first 80 or 90% feels very quick, and then the last 10%, solving the hallucination problem, for example, that last 10% is going to be like incredibly painful and long?
Yeah, I think that's probably spot on, right? Like, so I've seen really huge advances from OpenAI's models in their responsible AI and their safety. Like now, it takes a lot of clever prompt engineering is what we call, using different ways of talking to the model to get it to reveal interesting stuff. It takes a lot of clever prompt engineering to get it to say something bad. You have to be really clever and adversarial to get it to say something bad, which is definitely not the case from even a couple of years ago, right? So we've seen a big step function in that, but it's not solved. We've seen a big step function in inference efficiency. Actually, it's really exciting how fast inference efficiency is moving, but it's, even if you have the cost of a $5 generation, it's still $2.50 for a video.
And again, inference is when you use the train model to do something, right? There's the training part and then the inference part, which is when you use a model.
Exactly, to get your actual result out of it in real time. So every time the user wants to call the model, it might cost, tens of cents for a text model or dollars for a video model. And so you have to come up with the right use cases that are worth that. And, we don't have endless VC money, unfortunately, for everybody to blow through like OpenAI is. So I think we have to figure out either how to make it cheaper or like find business models that justify those generation costs.
Do you think this acceleration we've experienced, is that in some ways just the beginning, or did everything come together in the last few months that had been building up for the last 10 years and then this is going to plateau? In other words, are we at the beginning of the exponential in terms of AI progress, or was that just like a moment we just had?
I think we're still early. I think for two reasons. I think one is to Melanie's point, the amount of tuning and optimization across the entire pipeline is really premature. There hasn't been a lot of work. Even the things like I don't know, maybe you guys know better than us, but like how to set your the learning rate hyperparameters and how to tune your network efficiently for these kinds of models, and how to parallelize even. There's so many very fundamental questions, technical questions that really no one has seriously investigated. So on a technical level, I think it's very early. And then the other part is on a deployment level. If you look at the number of startups, the startups that are formed every day and announced every day, there's kind of like a startup formed for every different piece of software interface. Jasper, I think, is one of the first to kind of make it big, but it was like a startup in marketing. There's a really nice one, Spellbook, in legal. There's another, there's another one. I don't know how Adept, contextualizes itself, but it's either in RPA or automation. But you can imagine at every point of interface with a software application, there's gonna be a point to have a large language model in that point of interface, and I think all of those will be interesting and useful. And I think as all of those interfaces, become large language modelified, I think we're going to learn a lot about what it means to have that in the middle.
Yeah, I guess I will also add there's the other wild card of these models will start helping to train themselves as they get better and better. Like already, so with ChatGPT, their previous models, they showed that human instruction and feedback to the models is incredibly important. So you train the basic model, and then you get humans to tell you like how to refine that model and make it better. And their model itself has gotten so good that they now need like extreme experts to be able to train the model. So we saw an ad for their annotators, which are the people who like help give feedback to the model, and they asked for like top 10 percentile chemists, biologists, doctors, lawyers. They want really, really advanced experts, whereas like just a couple of years ago we were training with people who are paid minimum wage on like Matt Turck, right? So I think that is accelerating still. We're going to see that these models actually are starting to generate better data than the average human, and maybe can help train themselves.
So AI training AI. Nothing scary here, right?
Yeah, and that's already happening. It's not sci-fi, right? Like, so I think a very popular use of these LLMs is to generate synthetic data to train other models, because they're really good at generating sort of long-tail data. For example, hate speech. They can generate, unfortunately, all kinds of hate speech that you can imagine if you don't put the right precautions in place. And so you could use that to like train a hate speech classifier.
Yeah. So maybe to close before I open to questions from people, you know, the big question to all of this that you know is both fascinating and scary is like the path to AGI, so general intelligence. There seems to be two camps. There's a camp that's saying you know, we can brute force our way to it by having ever larger models, and there's another camp that says, well, no, you need reasoning. What is your take on this? I mean, is this exponential acceleration bringing us to this universal AI that can solve all problems for all people? That's an easy question.
You know, I think I kind of think human intelligence is a little bit overrated. So I think I'm a little more bullish on AGI. Someone wrote, you know, I think it was Ilya Sutskever, you know, maybe the largest models are slightly conscious. I'm not sure I disagree. So yeah, I think we're on the path.
I definitely believe it's possible. I don't know if it'll be the exact architectures we have now, but I think some of the techniques that we have and some new ones